Alright, so let's take a look at problem number 7. The directions are the same. We're looking at the graphs of functions, and we're trying to identify intervals on which the function is increasing, decreasing, or constant, and also identify if the function is an even or odd function, if it has symmetry with respect to the y-axis or with respect to the origin. We enter the graph from left to right, and as we enter from the left, we see that we hit an arrow. We interpret that arrow that it's giving us two pieces of information, that as x is approaching negative infinity, y is approaching positive infinity. On the right hand side, as you exit the graph, that it's going up and to the right. To the right is positive infinity, and up is also positive infinity. So we can relate this idea of increasing, decreasing, and constant to our idea of slope. As I come in from the left, I'm going down. So as x increases, as I move from left to right, the y values are decreasing until I get down to this minimum point down here, and then it changes and I begin to go up. So here on this interval, as x increases, y is also increasing. Then there's another change. So it's kind of a roller coaster ride, isn't it? You're going down, and then all of a sudden it changes, and you're going up. Alright, so it's increasing where we've highlighted it in yellow, that as x increases, to stay on the graph, the output of the function, the y values are also increasing. So we need to use these endpoints here, the x coordinates of these endpoints, to describe this yellow interval, this yellow shaded region. I'm going to have to eyeball it here. It looks to be, I'm just going to call it negative 1.5. You can call it negative 1.4 or whatever. It's somewhere between negative 1 and negative 2. And then the x coordinate here is 0. Or, and the mathematical symbol for or is a union, looks like just a capital U. Then the x coordinate here, let's go ahead, it appears to be symmetric with respect to the y-axis. It appears to be an even function. So if this is negative 1.5 over here, let's call this positive 1.5. And that's going up to the arrow up to positive infinity. So if you pick any 2 points in this yellow region or in this yellow region, as x increases, y will also increase. Now it's decreasing. As we hit this arrow here, it's negative infinity. We approximated the x coordinate of this point, this minimum point down here, to be negative 1.5. No reason for it to change. Or we're in this portion of the green part of our function that is between 0 and we said 1.5. It doesn't appear to be constant anywhere, so it's never constant. And the left hand side does appear to be a mirror image of the right hand side, with the mirror being the y-axis, so it is an even function.